Hey y'all, it's Miss Power. I think this is the first video of the year. I usually make videos for reviews for tests. But here we are with a video for Classwork Notes. I am gone on Thursday. This is not Thursdays. This one's Thursdays. This is Thursday's classwork. If your group is stuck, if your group read these instructions and just is lost, here is the video on the Google Classroom that will give you a jump start so that your group can work together and turn this in by the end of class. Nice. All right, let's read it together first and understand what the question's asking. Topic: investigating perimeters and areas. Adam and his brother are responsible for keeping their horses. Blah blah blah. Boop boop boop. Horses eat all the grass inside the fence. Moved around. All right. The porta fence consists of 16 separate pieces of fencing, which are 10 feet long each. So there's 160 feet of fencing, and they're in 10-foot pieces. That's the first useful information we've gotten so far. Brothers have arranged the fence in a long rectangle with one length of the fence on each end and 7 pieces on each side. So generally, they do 10 by 10, 70, 70. And then the area of this is 700 feet squared, where this is feet and this is feet. Okay. Adam has learned in his math class, then a rectangle can have the same perimeter but different areas. This is what we did the other day, where we decided that we could have skinny rectangles or fat rectangles or things that look like squares, right? But are actually still rectangles. And the perimeter stays the same, but the area changes, right? The perimeter will always be here, 160 feet, but the area is different based on how we arrange these things. We're wondering if we can make our daily job any easier. So we want to kind of do the same thing we did the other day, which is list out all the possible areas of rectangles where the perimeter is 160 feet and then find those areas, right? So over here, they've given you the length. They've given you the length already. You need to figure out what the width will be. These ones, these columns are in like fence blocks. So how many sections of the fence? Whereas these two columns, it's basically the same exact thing, except we convert it all the way to feet. So like one fence block is 10 feet. So basically the red column and the green column, I'm really not doing well with that. Hold on. Red, green, colorblind is like the most common one. We'll do blue. Here, feet. So the red column and the blue column are saying the exact same things, just with different units. The red column, the first two columns, are saying it in fence block units, and the two next ones, the blue ones, are saying it in actual feet. The perimeter is always 160 because that's how much fence we have, and then the area will change. And I want you to find the area by doing the area function, which is length times width. Okay. Discuss Adam's finding. Explain how you would rearrange the sections. So this one is just which one has the biggest area. 7, make a graph. You want to make it so that whatever the largest one is, right, that's the top of the y-axis. So draw your units, draw your scale, something like this. Like say the top one is 1,000. You want this one to be 1,000, and then you can section up everything after that. I don't actually remember which one is the tallest though, so you have to figure that out. But label your scale, right? And I would do like this is length, so 10 feet is the length, 20 feet is the length, 30 feet is the length, etc. And then this one is the area, and it'll get up quite high, right? It'll be at least 700 will be included. What is the shape of your graph? This is either going to be like a straight line or parabola or exponential curve, right? If it's linear, if it's quadratic, if it's exponential, it'll have different shapes. So we can kind of see what shape it's making on our graph and name it a number 8. And then number 9, spoilers, it's quadratic. I want you to tell me in all of these different representations, what were the clues to let you know that this was a quadratic function? Great. Y'all, that's the classwork. Once you finish this, and I think you'll be able to finish this before class is over, pull out your 1.6 packet that we started on Wednesday and work with your group to try to get a couple more of those done. Check what you did for homework against each other and keep on working. You'll turn those in tomorrow. All right, bye.